Guys, this is just a sample of how we collect data for our Barbie bungee drop. So I rigged up a meter stick here, starting with 0 at the top. And I'm just gonna test out how far Barbie falls with elastics on her. So in class, I showed you what it looks like with 0 elastics. It's just her height, which is about 29 centimeters. Then we tried 1 elastic, 2 elastics. Okay, what if we try 3 elastics? So I'm just holding her up here, holding the end of the elastic on the meter stick, and then I'm gonna see how far she falls, which is like really hard to tell where the bottom of her head lands, because then she bounces up. So it's nice to just try it a couple times. And then if it gets caught on you, you're gonna redo it. Okay, so I was going with, I forget what I said for this one. I think 3 elastics was about 66 centimeters. So that looks like the lowest spot her head drops to, approximately. And then we just keep adding elastics. So then we try 4 elastics. What do we think she rebounds to? Oof, pretty low. Down maybe around 84 centimeters. And then I think if we try 5, it's gonna be longer than a meter. So I'm gonna stop there. This is just to help you figure out Barbie bungee drop, how to write it out. So if you're struggling, here's an idea for you. Okay, so this is the scenario. We want to figure out, let me just go with the overview. We're on the 3rd floor of Bernie Custis. And we have to so we're on the 3rd floor railing here. This is going to be a really horrible drawing. There's like the stairs all the way down, you know? And we've got Ken down on the 1st floor. And so Barbie, I'll just draw her in another color. She's up here, and she is going to bungee jump all the way down to Ken. Now, we measured the distance from here all the way to the 1st floor to be 9.51 meters, I believe it was. It's in the info for Barbie on OneNote. 9.51 meters, which you might want to convert into centimeters. So we know the distance Barbie has to drop, but we need to figure out how many elastic bands do we need to attach to her so that she's able to fall this distance. So the question you're trying to ask in this assignment, the question you're trying to figure out is, how many elastics do you need? Do we need to attach to Barbie so that she can make it down to the 1st floor to help Ken? So how would we know that? So each elastic's going to have, well, you know what? The best way is to trial it out, to make a model of the situation. So in class, I showed you, well, if we attach 0 rubber bands to Barbie, and toss her on a bungee jump, we figured out, you know, if we just throw her upside down, she's about 29 centimeters tall. Then we tried, okay, what if we attach 1 elastic band to Barbie? So now she's going to stretch out, so let's say that's her now. Now she's going to stretch down to about, what did I say, 41 centimeters. Then I tried attaching 2 elastic bands. Those are her feet. Now how far is she going to fall? So we just keep measuring it. We're doing trials so that we're able to see what kind of a relationship this scenario holds. Is it going to be a straight line? So 21, 41, got about 51 centimeters for 2 rubber bands, 66 centimeters for 3 rubber bands, and 84 centimeters for 4 rubber bands. So we're not really sure what kind of a relationship this is. These guys ended up being greater than a meter, so I didn't measure them. So we've got 5 pieces of data here. So what I would suggest, the most accurate way to figure out exactly how many rubber bands will get us to 951 centimeters would be to make a graph. So figure out, graph this table of values. So you should be able to figure out what's going to go on the x-axis and what's going to go on the y-axis. Create a scale and draw a graph. you're going to be like plotting points. So since this is a grade 9 course, we're hoping, because we only really know linear, we're just going to assume actually that this hopefully makes a linear relation. So we're going to draw a line of best fit for our graph. And we're going to determine the equation of this line of best fit. And that way we're able to extrapolate this information. We're going to be able to kind of extend our line of best fit or use our equation to figure out exactly how many elastics do we need to reach 951 centimeters. That is our goal. So basically you're answering this question: how many elastics do we need to attach to Barbie? And you need to have some mathematical way of showing it. This would be the number one way: to make a table, model it with a graph and a line of best fit, determine the equation of this line of best fit. Remember, equations of straight lines are always in the format y equals mx plus b. Like instead of y and x, maybe you'll want to label it r and d, whichever one you think fits y and x. And then that's it. So I hope that helps a little bit. I know it's a tricky assignment. Good luck.